Variant is a C++ feature introduced in C++ 17 standard. It is an improved version of the C style or plain union. Specifically, variant is a type-safe alternative to the traditional union. Therefore, I will first explain the plain union and then I will discuss variant. A plain union is a user-defined type similar to structure that allows storing data of different types in the same memory location. The main problem with plain unions is that they do not prevent access to data of the incorrect type. Variant is a safer alternative to unions, with features that ensure only the correct type is accessed. Let us learn plain union through coding. Here, let me first describe the context for the union. That means why we will need to think about having union. For example, I want to create an object, let's say called D1 of some type, let's say data, and I want this object to be able to store integer type data value and double type value or character type value, but I want this object to be efficient in terms of storing the in terms of the memory requirement or amount of memory space required. That means I want this object to occupy memory space that is sufficient to store either this data, this value, or double value or integer value. That means I want to have memory space where I can safely store integer value or double value or character value, and but not all the values together. If I am storing double value, then I will be only storing double value. Integer value will not be I will not be able to store integer value, or I will not be store character value. If I am storing the integer value, then I don't want to store double value or character value, right? If I want to store character value, I don't want to store integer or double value. So only one data to be stored at a time. That will help to minimize the memory space required, but it has some constraints. So in this case, the memory required would be the largest memory size, or memory size that would be required to store the largest size, the data which requires the highest memory space. In this case, a double type would require highest memory space, which is 8 byte. Integer type requires 4 byte. Character type requires 1 byte. So this object will have 8 byte memory space, and in the same memory space I would be storing integer type. If it is time for me to store integer type data, I would be storing double type if it is a time for me to store double data, and I would be storing character type if it is time for me to store character data. So this is the requirement, and this requirement for this requirement the type union type is the thing that actually it fits this requirement. And I for this, if this is my requirement, then I would create this data as a type union type. Union type is similar to structure. For example, if I have a structure, if this is struct data, and I want it to be able to store integer type, let's say x, double type y, and character type g. So in the case of a structure, if I create an object of a structure like this, then D1 will have memory space to store all data, 4 byte for x, 8 byte for y, and 1 byte for z. But um, similar to structure, you can also create union by replacing this struct keyword by union. So this is the syntax for creating a union with which is able to store either integer or double or character data at a time. So if I want to see the size of D1, it will not be, for example, let me just begin with structure, and if I want to see the size of D1, and I will see so it is 24. So if you look at the members and count 4, this is 4, and 8 byte, and this is 1 byte. So if you add all these things, it will be 13 byte, but because of the alignment requirement, it is 24 byte memory space in this case. But if I want to create a union, so for union data, union type object will have a different memory requirement. It's going to be 8 byte. So it is only 8 byte. So here, that same 8 byte will be used to store double type data. If it is used to store double type data, the same 8 byte will be used to store integer type data, and same 8 byte will be used to store character type data. But you cannot store multiple members data at the same time. You have to be storing only one data at a time, and if you want to store integer, then only store integer. And that if the utility of usefulness of that integer data expires, then you can reuse this object to store some other type, maybe double or character. So that has to be the way, I mean, that is the way you should be using it. Now if I want to store integer data, then I would be doing just trying to you can use this object D1 to access that member X. Remember, this is accessible from the outside. That means like in the case of structure, these are public members, they are accessible, and equals to 24, and you can use it. In this case, I'm printing, and then if I don't need to use that X anymore, then I need to use Y. Then I can Y equals to, let's say, 22.22, and then after that D1 dot G equals to A. So if I use like this, then it should be okay. I will not have any problem. So 24, 22.22, and A. So you can see 24, 22, A, right? So without there is no problem, but the problem arises when we have this data is stored, but I actually attempt to access another data. Here D1 dot Y, or you want to access D1 dot G. here as well. You try to access let me access all three, x, y, and j, and we have x, y, and g. So let's see what we see in this three access of all the elements in all the three cases. So you can see in the first case 24 is access is correct, but in access of other values you cannot make sense of what is it. Okay. In the second case, the second data carried by the second memory is correct, but first and last doesn't make any sense. In the third case, this is data, but it also looks that the second data is correct, but it is actually not correct, because A only occupies 8 byte memory space. Sometimes it may happen that in the place where A would be stored, this content will have only 0 bits or maybe minimal bits, maybe that may not amount to fraction of this number that would get displayed in this place. So in the third case, you have to assume this is correct. This is not correct. So if you attempt to access the data that is not currently stored, then the behavior is actually not defined, undefined behavior, you can see. So this access is not desired. These two accesses, in this case this expression is not desired. In this case these two are not desired, because we have stored in the first case we have actually stored integer data, in the second case we have stored double data, and in the third case we have character. And how do you actually do this thing? How do you handle this situation? One way of handling is traditional way of handling is to keep track of which memory is currently being used, right? So to do that, usually people use enumeration. Let me call this type. Type is the name of the enumeration, and the symbolic constants here I, integer, double, and C. I'm just using a single characters. And you also want to have a variable of this type actually to carry. Maybe we can have that here. So types, and then let me call this current type. So once you actually set the data, then you immediately carry the corresponding type in this variable. So equals to types and I. Right, so this class, because of this class in the previous before 2011 standard, you didn't have this class, so you could directly use this names without putting this prefix here. But this is something called scoped enumeration. So you need to specify the scope in this case, and this is the way you actually tell compiler about the scope of this symbolic constant. And in this case you would be setting and here character. So once we have this information, then we we don't want to display like this because we don't want to access incorrect type data. Rather, we could do something like this. Um, Maybe we can have a function to print void print, and which will receive data and also the type. I'm passing by value because this is passing by value will not cause bit of overhead here, so it should be it should not be complicated because it's a simple one number it will be passing here. So put this cout statement, not one, and let me create inside. So what I want to do is I can put that current type in the switch um, and current type, and then inside case the option for this data option for this variable are this I, G, and C. So I. Maybe I can put this thing here just wanted to minimize the code. So you access dot x, then case double y, case and character, and then after outside the switch scope, I want to display a new line character. I want to insert. So this is the code I have here to print that data, and this data is a union type, and if current type is holding this symbolic constant, I would try to access x because we when x is set, then we set this types I, and if it is double y, then we have this current type will be carrying this D and C in this case. So if it is I, then I would access only x. If it is D, then I would access y. If it is C, I would access Z. So I can call here print D1 and type, right? And I could do same here, and also copy paste. So in this case I expect that only this function will actually select the correct type or the variable with the correct type based on the information that is carried by this argument. Let me make sure that this code actually doesn't have any problem. So in the first case it is 24 displayed, 22 and 22, and then 8 displayed, right? So it is working. Another a bit more realistic case would be uh, something like this. Uh, for example, I have a, a student, structure, and I want to have a name of a student, and I want to have a grade as a union. Let me have a union. You can also have union inside if that union is not used to be, is going to be used anywhere else other than this structure, inside structure, but let me put it outside. Grade has I mean you can, the expectation or the desire here is that I want to be able to use this grade type object to store either the grade in letter form A or A plus, something like that, or I also want to um, use a percentage 75, right? So int percentage and character letter, because I want to be able to store first character, second character, and the null character. So three elements. So we have this union, and I also want to have something like I mean the type to track the which element is actually used, which member is currently being used. So for that I need to have um, enumeration. We can call this as format. It could be percentage format or letter format. So grade formats, call this percentage and letter. Now here as a member of the student I can have grade. This is the object of this union type, and then I also want to have a variable of this format type. So this is the structure I want to use, and with this I can create an object of this structure student, and here struct. So type followed by name of object. Let me call this s1 and equals to initialize it to, let me call the name, the first element is a string name, and second you need to have the data for this grade, right? So it has two members, so you can do something like this. If I give a percentage, I think I could give something like this 78, and next is this is the symbolic constants. This is this should be related to the nature of this one, format of this. If it's percentage, then I would use percentage, right? So in this case and I will come back to this to demonstrate how you will be able to also set the letter grade in this case. First let me make sure that I can use this object. So to use this object what I can do is I want to have a function called print. Basically it is going to be the overloaded version of this function. So because the type I'm going to be putting is going to be different, it's going to be student, so I can use the print name, and pass S1. And I don't need to pass the type here because type itself is a I mean member of that object itself, so it goes with the object inside. So I want to have a function print and accept the parameter type is going to be constant student reference st. Here inside I actually want to print in the format like first name and followed by maybe comma and grade, and I don't need to print this format because I will be using this format just to determine which grade is currently being used. So it could be percentage or letter grade. So you could do something like this, std cout, and the first then go have name st.name. Then I want to display grade. In the when you display the grade, you need to make sure that you need to be you should actually be checking this constant. Based on that, if it is percentage, you display as a percentage number, or you access the percentage member. If it is letter, then you access the another member, right? We have two members, percentage or letter. So based on what value this format carries, you actually select corresponding member. So we could do something like this. I can have a conditional expression here, and in the conditional expression I would be comparing st.format equals to, if it is let's say grade formats, and if it is number, then st percentage, otherwise it's going to be st I think I should remove this here, and at the end let me insert new line character. Right now let me compile this. I think I will get some error in this place, because this the type of this expression and this expression has to be the same. If they are different, then compiler will complain, because here percentage type is integer and this type is character array, character pointer or array. So let me first see the error, and I will come back and try to fix this problem. So it is complaining number is not member of let me go back. I think that I got a different error than I expected. So this is not number, this is percentage and letter, I think. It should be percentage here, right? So let me try it again. So now I am getting the error that I actually expected in the beginning. So this type, this percentage integer type, this is the constant character pointer type. So they are not same, they have to be same type for this expression to work. So to make it same, I would be doing maybe I would be converting this into a same type. Let me I want to convert this, both this and this, to, let's say, std string type, this type. So to convert this number to string type, I have a function called toString, and if I have this string, I also want to put that percentage character at the end, plus percentage, and here this is a constant character pointer, so I actually want to also convert this into a string directly using this class. So this will actually display either a plus, b plus, a, b, c character, and this will display, let's say, 75%, 78%, and so on. So let me try it one more time. So the error prone is gone. Now we have this thing displayed. We have 78% and the name and the grade, right? So back to the code. Now if I want to actually initialize this with not 78, let's say a plus, and this is going to be letter, then make sure that it is letter. So this thing, and let me try with this, see whether it works or not. Now it is not working. It's not accepting this constant character because the reason here is that, let me go back to the code and talk a little bit. So it will, when you put like this, it will, I mean, try to assume, it will assume that this is going to be the first member of that union. So but we have the first member of the union is the integer type. So you need to mention, be a little bit explicit in this case, just to make sure that compiler knows your intention. So a way of doing that is put inside this curly braces and just do dot letter equals to, right? So it will actually select that particular member and copy this data into that member. So now it is displaying the grade is a plus. Now once you have this object, then you use this object, then at some point of time you want to change the format of the grade, then you can use this. You can do that this way, s1 dot grade dot percentage equals to, let's say, 91, and also you need to set the format, s1 dot format equals to grade formats percentage, and then you actually call print function. Right, so let me try this also. So now it is 91%. Now few important points about this union. So it actually helps to save memory. So you can, if you need to use only one memory at a time, then you can use this type, union type, if use of only one memory is sufficient. And second thing is this kind of situation, this requirement often arises in low level programming. Or embedded systems. Because the resource is very scarce in the low level programming, you want to minimize the amount of memory space occupied. So you want to use different kind of tools that actually allow you to minimize both the memory and also minimize the computation. And also the what you need to be careful about is you make sure that you track which memory is being used currently. Like in this case we have used this type, or in this case, in the case of a student, we have used this variable to keep track of which format or which member of this grid is being currently used. So keep track. And also, as I mentioned you earlier, these are public. These members are public, like in this structure. And with union, inheritance is not allowed. These are the few points or few things about union you want to keep in mind. Now let us learn about type safe union called variant. And with variant, I will also talk about get, widget, and holds alternative functions that are actually sort of utilities that you can use with variant objects. So I will continue with this code. This was the code that was produced from the previous discussion in the earlier part of this recording, this video. So this type safe union or variant was introduced in 2017 standard C++, and it allows to hold the value of one type out of all the set different types, right? So main advantage of this type safe union is that unintentionally, for example, in this case you need to carefully keep track of the which member is currently being used, but if there is an attempt to access member, like in this case, then compiler will not complain. Compiler will allow access, and then if that happens unintentionally or intentionally and that data is used, then that will actually lead to unpredictable behavior. So in this case in the first case data 24 is valid data, but if you attempt to access or read other members, then you will have this kind of data. And if in case if you happen to use this data in your program, in your logic, then the outcome of the logic cannot be determined. It's unpredictable. So type safe union actually helps to prevent that this kind of situation. It will prevent this kind of access to invalid type from going into the runtime. It will prevent that in the compile time, unless you fix that issue at the compile time, and then you I mean you cannot I mean complete, I mean you cannot have the program that can execute, right? So if compiler stops, then obviously you'll not have a program that can execute. So let us learn about this. uh, to create a variant, for example, I have this data, and this is the union data, and if I want to create a variant, I need to include the library first called variant library. It will give me access to a class called variant. That class I can use in the place of this data, and I don't need this enumeration in this case. So let me comment this out, and right, so let me directly create that. Suppose I want to create the same name object, then I would use this syntax std variant, and and after this name of the class you put this angle brackets, and inside angle brackets you put the list of the types, right? So first member I want to I want this variant object to be able to store is integer type, second double type, and third is character type. And after that you give the name of the object. In this case I'm going to be using d1, the same name that I used before here. And I don't need this uh, variable to keep to track the data being used, type being used. Now in this case I don't think I would want to see the size of the object. Now you can now this object doesn't have the member x, y, and z, so you don't want to access x. If I want to set this object to integer type, I would do directly like this: d1 equals to 24. And this is also not necessary in our case here. And I also don't want to have this cout statement. And I also, let me also comment this out, right? So if I want to actually display this data, then I would be using a function called get. You can call this function as a utility function that you can use with a variant type object get, and you need to specify the type you want to get, but you need to specify the correct type, int, and you put that object d1 inside. So this will give access to this data. If I set this d1 to double afterwards, and comment this out, comment this out, and comment this out. At this point you actually tell compiler it is a double type you are interested to read, d1, and again let me have d1 equals to character, comment this, comment, comment, character type. So this is how actually you can access. Let me compile this, because I have not lost the student type, so this should compile without any issue. But I would be interested to see the outcome of this cout statement, this statement, and this statement. So let me go to the terminal. mm. I think this the problem is that this uh, let me go up to the top and see the first error we get here. I have used data, but data is not defined, so I think I should have defined data. So I should not have commented that out, this thing. And so it is complaining that it is I mean, this was introduced, as I told you earlier in the beginning, it was introduced in 17 standard, but I am actually using um, this 14 standard. So I need to fix this issues, and then I'll come back and compile this using 17 standard. So go back to the code, and because you know this data has been used in this function. Either you, if I have not used data here, then I think I can comment that function out as well, because I will not be calling this function as well. So comment this out. And let me go back to the terminal one more time and clear. So at this time I will compile using 17 standard, so no error. So I was interested in looking into this three lines. So it has been displayed as expected, 24, 22, 22, and A. But if you set this object to integer type, but if you try to access double type, because that is the main reason why we have this, right? So I told you earlier, if we call this type safe, then it should be safe. It should have feature to um, ensure that it is safe with respect to the type. So let me see the error I will get with this. So you know, it is not displaying properly. That means there was some exception that happened here. So when you attempt to read a different type, I mean incorrect type, then it will throw an exception. Either you handle this exception. I'm not going to be talking about the exception at this point, so I will tell you or discuss a different way of handling this situation. So you want to make sure that it is integer type, then before you actually use this get function for integer type, right? So for that you can use one function which is called std holds alternative and int, and you pass object. So this entire expression will return true if this object t1 is currently carrying integer type object, integer type data. So if this is true, then you access it here, otherwise you don't do that. So if you have this safeguarding, then your code will be more safe. I mean, there will be It will help to avoid unintentional attempt to access or read a different type from the this object. Similarly, you can have this if condition here for double type, and you have if condition for character type. In this case, if for example, if I try to access this, then I would be putting that in this if statement. For example, here if I want to call this function with double, then I would be putting this if so this will return to, this will evaluate to false, so obviously this statement will not be this expression will not be evaluated, or function will not be called. Let me see this in the output. So first 24 is displayed, that called, and 24 is displayed, and 22 when 22a we don't have this exception issue like we had in this case. Right, so this is a way that you can these are the tools that are available for to be used with variant type object, variant object. Now if I want to use a variant for, let me clean this up because we are not using this, so it's a good idea to make it look clean. So if I want to use this variant for a student, I cannot create object like this because student is a structure. I can replace the union type object for by the variant object. So in this case the union is grade, so I can replace this this thing with variant, and in that case I don't even need to keep track of this thing, so I can comment this out, and this comment I would have variant, and then it's going to be integer and character. It's going to be, I think, character pointer. It should be so character pointer, because this is letter is a pointer to the character, and call it grade. Right, so we have some changes in the student structure, and we will have to do some changes here, and let me first do change here. So for this I can let me comment this out. So to create object student is going to be s1 equals to, the first name is already there, so you can set a name like before, but in the case of setting variant we have to be a little bit great, we have to be a little bit careful. So name is going to be same, a section, and here let me try a plus. I suspect I will run into some problem in this case, but first I want to see the problem. What problem? What is the problem that happens, and then I'll come back. I think first let me use the normal grade. So let me use 91, and I actually want to fix let me comment this out because this may cause a problem. So let me make sure that this statement doesn't have any problem. So try to compile it. So looks like that statement, particular statement, doesn't have the problem, but the problem is inside the print function. So going back to the print function, I actually, as I mentioned you earlier, you need to do some changes here because the members have been changed. So what we can do here is maybe try to use something similar to what we did here. Maybe try to use this function and check whether it is of certain type, then use this get, this kind of get, otherwise you use other kind of get. So if student, I can use this thing. Let me just remove everything here. So what you can do is alternative, and you want to check whether this is integer, and the object you want to pass inside is grade, and if it is integer, then you want to convert that into a string, and before you convert you need to get this get function, but you want to get integer type from grade object, right? Otherwise you get character pointer type from grade, but you need to, because this character pointer, to make it uniform for this case, you want to convert this into a string type. Right, and also if you have this grade, number grade, then you want to add percentage at the end, so plus percentage. So I hope it will work. But so let me try compile and see whether we have any issue or not. Sorry. Now, yeah, it looks like it is working. We don't have at least we didn't have syntax problems. So we can call print function here. So it is displaying the grade percentage. Now if I want to, instead of percentage, I want to insert pass letter grade A plus, let's say. Now we have the problem. The problem is that the type mismatch. So this is the constant character pointer, but this variable here, it is this is the character array. So just to resolve this issue, what you can do is maybe create a character array, call it let me call this gr equals to a plus, and pass gr into it, right? So let me try with this. We didn't have that one. Yeah, it's not, now it is displaying a plus letter grade. So if you want to change that the grade to a different format, for example in this case it is letter grade, and in the meantime if you want to change to the percentage, then you just set this grade to that integer value. So it will be changed to percentage. Then if I print, then it should be printing in different format. This print and this print statement should print a different format. In the first case, it is going to be letter grade because it was the letter grade that was passed, and then at this point we have changed it to the integer grade, integer percentage. So this is the percentage, grade in percentage and grade in letter. Now I will talk another feature or another utility function that is designed to be used with this variant object. Instead of that function will make it even easier to display this kind of things, right? So that is called something called widget, std widget. How it can be done is this is a function like which receives two things. First, some logic that you want to apply, and the second is the object that you want to pass as an argument to that logic. So if I have object called d1, then I would pass d1 here, but you need to put a logic here, right? So logic can be if you're familiar with lambda expression, you can use lambda expression, or if you're not familiar, then you can create a function to be passed there. I want to actually because we have the three different types, so I think it is logical, reasonable to have a template function here, t, and I want this function to if you want this function to just display the data, you can have a void return type and print and then t, and then call this parameter name x, and you actually display x. Right, this is a simple. You don't need to use a get in this case. Just insertion of that item into the output stream, and you can use this print function in the widget here. But it is since it is a template, so you need to tell for what type you want to use this function, right? So this statement should actually display this data d1. I think in this case, in the last case, it was a, so it should be displaying a. So I think there's some problem with that. Let me go back and check. So print int, we have d1. Let me use a different d1 equals to 25 and try with this and see what happens. Yeah, it is displaying 25. It should be displaying a. I don't know why it is not displaying. Let me set it to a, and in this case, oh yeah, I think the problem was that it was a, but we actually specify integer. So if it is a, we should have character here. So we have a displayed in this. Now it's also possible that you can have this templated function return the value. I think let me so if you can also use this with value return. So you can also, if you want to use this function in this fashion, std widget, and then you want this function to return the value, put these things here. In this case, let me set d1 to 22.33 and double. But you cannot use this as it is, because the print function we have actually returns a void. So this insertion of expression will actually expect something to be placed in this place. so you can replace void there. So you can create another function that would return something. In this case, I can just return x. I guess it's going to be simple. Return t, and then right. So this function, because this function is going to be used in this place. Okay, I did a small error here, so there's a problem having the same function name here in both cases. So maybe change the name of this function to, let's say, get value, and use this function here. So let me try with this. Try to see output. Now we have the return value has been inserted into the output stream. Let me stop now. Thank you for watching this recording.